Hello and welcome to another episode of AI Buzz. Thanks so much for joining me today. Today we're going to talk about yet another component of personal machine learning workstations, and that is the cooling system. So the two main components that need to be cooled in a machine learning build are the CPU and the GPU. We can start off with the CPU, and really what's going to happen here is cooling is going to enable you to effectively overclock your CPU and eke out some additional performance that you might need during data loading, data preparation, and model training if you're not using your GPU to train a model. There's a handful of model types that end up being better off just sticking on the CPU for training. Before I start machine learning for the day, I'll always overclock my CPU and crank it up to a reasonable level that I want it at for that session. I don't have it as a default setting because my workloads are pretty inconsistent in terms of CPU demand. Email and YouTube are not really going to require any sort of overclocking, and I just don't want to burden my CPU more than it needs to be if I know I'm not doing any heavy duty tasks. However, when I want to do data transformations on gigabytes of data at a time, going to want to crank that up for that particular session. So really get used to your CPU overclocking interface. So this is your BIOS typically, and get used to cranking it up before you're doing these types of tasks. And what I'm going to talk about today is going to help you to kind of compensate for that additional load on your CPU and keep it nice and cold. Linus Tech Tips as well as TweakTown have done some really good studies and comparisons with different cooling systems that should translate pretty well to machine learning. And that's one of the similarities between a gaming rig and a machine learning rig is both consumers for those types of use cases want their components to be icy cold. So that being said, what should you be looking for in a CPU cooling solution? The metric that we're really going to want to focus on are the thermals, or the temperature of the CPU under an extreme load. And the company TweakTown conducted a awesome test where they compared a lot of different types of coolers for an overclocked CPU. And in this test, the Arctic Liquid Freezer performed best. This is one of those all-in-one type of cooling solutions where you have cooling liquid refrigerant circulating across the face of your CPU, keep that nice and cold. That gets circulated up to some fans as well as a radiator that's further going to dissipate your heat. I'll put a link to that in the description. I have a Corsair all-in-one cooler. This works great. It looks really cool too, and I know that it keeps my CPU extra cold. That being said, this article from the company TweakTown, it really had some nice results and a really nice experiment that they had conducted. So I'm actually considering someday upgrading to this liquid freezer. It was amazing how cold it kept the CPU under those conditions. And I believe it was like a 3 or 4 degrees Celsius drop to the next best performing cooler. Anyways, let's move on to GPU cooling, which is definitely going to be more important for your deep learning workloads, since your GPU is probably going to be under load longer than your CPU. I'll let my GPU crank overnight if I'm working on new training data, so making sure it's cool is really important. You don't want this thing to be operating at really hot temperatures for that period of time. And for deep learning, you're especially going to want to be overclocking your GPU, and that can be done in that same BIOS interface I was talking about earlier, if you're not familiar. And this is the same place you're going to be adjusting your CPU clock speed. Air coolers for GPUs really seem to be a good balance between performance and price. Reading the different Amazon reviews for some of these GPU air coolers show that a lot of people really like how they perform and keep those GPUs nice and cold. Specifically, the Arctic Accelero Extreme looked really good. One review I was reading about, the user was able to overclock his core frequency by 200 megahertz and the memory by 600 megahertz. So he got a huge performance boost out of his existing GPU for just adding a GPU air cooler to it. So definitely check that one out, or consider maybe another type of air cooler to keep your graphics card nice and cold, because it's not a quick task to usually train a deep neural net. It can take a long time, and if your thermals are all messed up, it could, worst case scenario, even damage your graphics card. So definitely try to avoid that. Another important consideration is to avoid having GPUs right next to each other if you have a multi-GPU setup. If they're in close proximity to each other, they're going to transfer heat and degrade each other's performance. If possible, try to stagger the placement of your graphics cards. A lot of motherboards will have 4 total slots for graphics cards, and say you have just 2 GPUs, consider putting them in slots 1 and 3. Give them a little extra breathing room so they don't directly transfer heat to each other. If you have a really crazy machine learning workstation build and you want to have 4 GPUs in your one workstation, definitely consider checking out a water cooling solution. That's a scenario where air cooling won't even cut it, because there's just not enough breathing room between some of those middle sandwiched GPUs. So water-cooled GPUs is not something I know a whole lot about. I've never had that extreme of a setup, but there's a lot of really good reviews and experiments and tests out there that you can check out. So if you have a 4 GPU workstation, definitely look at trying to water cool it, because those middle GPUs, it's going to be extremely hard to dissipate heat from them, and you'll notice a big difference in your temperature between those middle 2 and those outer 2. It's definitely one of my goals someday to build a pretty wild multi-GPU setup, so I can't wait for that, but that day is not today. It'll be someday. So long story short, for cooling and machine learning, check out all-in-one coolers, so circulating refrigerant, fans, and radiator-based coolers for your CPU, and one of the air coolers for your GPU. It gives kind of a good balance of performance and price from what I've seen. And think about spacing if you have a multi-GPU setup. As always, if you want any specific advice for your particular use case or your budget, I'd be more than happy to talk with you and learn more about what you're working on and see if I can offer anything of value and offer my 2 cents. Also hoping to make this more of a series too. So if you guys want to see another component that's required in machine learning workstations, let me know in the comment section below. And also consider giving this video a like and the channel a subscription. Thanks so much. Bye.